Variant process planning. Variant process planning consists of completing a certain scheme of indexing a design part, which allows to find the most structurally and manufacturing similar component and take over its manufacturing process it with an insignificant number of adjustments. Such approach to process design shows its benefits when it is possible to classify manufactured machine parts in groups of parts, which are structurally and manufacturing similar. VCAPP is therefore closely linked to the group technology of machines and use of flexible manufacturing cells. The effective use of flexible, robotized manufacturing cells is guaranteed by completion in such group technology idea systems. Hence, similarity of the machine parts process that should be considered both at the stage of design, equipment and software configuration and during everyday use of the production cells. The group technology, GT, method has reached its mature form at the beginning of the 1990s. Currently, GT is considered as a concept of production, in which production resource is functionally grouped in production cells for the purpose of processing machine parts with similar features in order to achieve a high level of production reproducibility and artificially extend the size of a production batch. GT is related to the cellular production concept, which means production both in flexible manufacturing cells and in autonomous flex cell. GT therefore involves a range of various operations of a design, production and organizational nature, which requires coherence and synchronization. Many of them, such as determining production similarity of machine parts, grouping and classification of machine parts, variant design, parametric programming of computer numerical control, CNC, machine tools, developing group manufacturing processes, designing group processing equipment, configuration of the manufacturing cells and the issue of planning and controlling the manufacturing process are still readily raised subject of development works. Technical implementations of VCAPP systems most frequently include one of the two solutions, building a system based on finding a similar part of a previously manufactured machine part and adopting its production process plan, or developing a group production process for the so-called synthetic representative of the group. In both cases, it is possible to use a process model developed in the Petri network technique. However, the second method is more natural in using its potential. Feature precedence network, FPN, defined as a directed graph representing precedences that result from limitations imposed by the features, is a precondition for designing a correct manufacturing operation. For complex parts, with a large number of processed features and relations between them, FPN might be very complex and very difficult to manually process. And has developed a system generating FPN based on the analysis of interactions between the features and verification of FPN using the Petri network model. The developed structure involves generating features by way of mapping from CAD system, analysis of interactions between the features and an algorithm automatically creating a Petri network corresponding to a given FPN. An analysis of interaction between the features involves comparing each pair of features with reference to the defined set of rules. These rules include heuristic preferences of processing sequence, which guarantee its effectiveness. The rules take geometric, production and economic factors into account. In case of variant approach to production process design, FPN represents a model developed for the synthetic representative of a given group of machines. The synthetic representative represents an abstract object that includes all types of features that can be found in the group of parts with production similarities. The process model should allow for an explicit definition of a processing task only by way of correct positioning of initial marking vector M0. The sequence of processing individual features is defined based on the FPN. Subsequent, structurally unified modules of the model supplement the remaining functions of the model. The work elaborates on this issue and gives an example of the variant approach for axially symmetrical parts.